Good day, everyone. So I am Iffat Humaira from MSc IT second year. I'm doing my post graduation in Stella College, Chennai. So I'm going to be talking about face recognition and the different mechanisms we have in that. So yeah, let me start presenting. So as discussed, my topic is going to be about the different mechanisms or different methods that have been employed in face recognition so far. So this is going to be a survey paper. Ms. Madhura Prabha is my guide, and we are from Stella College. So why was face recognition my area of interest? Because I really find it very interesting, when people, when the phone recognizes our face and it's able to, perform as a biometric. So that itself in our day-to-day life is a very good example of face recognition that a smaller device, even like a mobile phone, is capable of doing that. So and not only that, it is also used in the surveillance when people have some kind of criminal record. So how do we identify them? So even though they have this disguise on, so that's something that got my interest, and that was the reason for my research. So I have actually listed a few very commonly used algorithms that I have come across in the survey paper so far. So one of being the Viola Jones detection algorithm. So this is a very robust algorithm that has been used since a very long time, and because of its robustness, it has been coded as a special as a specific detector in the OpenCV library, which stands for computer vision library, and it has been coded in Python. So this itself is a detector program explicitly because of its popularity. So an overall idea about how Viola Jones works is it the color picture that gets recorded through the surveillance camera or through the uh, or through any forms of that sort. So it converts the colored picture to grayscale so that it is easier for the algorithm to process. Because in color pictures we have like with different variations, we have different pixels and all of the colors. So converting into grayscale before and then going in for the phase detection is the approach used in Viola Jones algorithm. So the next one is YOLO phase. So YOLO basically stands for you only look once. So the camera is straight. The whole idea of this algorithm is by just having a first instance or a first glance of the picture, it should be able to make the detection, and that is why it was named you only look once algorithm. So over the time, there has been many variations or many versions, I can say, of YOLO. So one of them being the latest is YOLO V3, which was in a performance wise, it was like very good when compared to the other versions. But the major problem in YOLO V3 was it failed to detect a face which was there for a very minimum amount of time or is very small in picture, like a background picture, like a background face in the background picture. So it failed to recognize that. So the authors or the inventors of the YOLO phase came up with a solution to that problem, where they had made sure that not only the picture in the face in the background gets captured, but along with that, even the face which is there for a very minimum instance of time, even that gets recognized very effectively. So they actually use MSC or the mean squared error to bring down the error rate. So when compared to YOLO V3, YOLO face was a very good upgradation, we can say, from the existing ones. And the next is boosted cascade of simple features. So this is basically where in the picture, like we also have some background pictures along with the face, which is not much of a use. So this actually removed those the background pictures. It actually discarded them and just caught the main area of attention, that being the human face itself. So it discarded those extra additions and just took the main point of focus, which is the human face. And with those pictures, it went on to apply the local binary pattern histogram. And that is nothing but in local binary pattern, what happens? the pixel value is decided based on the neighboring pixels around it. So once that was generated for the current face, it was compared with the existing faces or existing histogram values in the database to see if there was a criminal record of this person or this person who is being searched around. That was boosted cascade of simple features. And then comes the deep dense face detector. So as the name suggests, it itself is a very dense detector. But then the irony of this model is, even though it was having, like, no uh, it wasn't having any extra addition to it, but it was still able to give a very good result. So what it did was, it had something called a pre-trained AlexNet model. So that was AlexNet model is an existing one. So that was pre-trained and also fine-tuned to make sure that it performs as per the requirements of the authors. So it basically is a convolutional neural network for the first 5 layers, and the next 3 layers were the complete network layers. So a convolutional neural network is nothing but a special neural network which the main target is to focus on the image processing. That was the whole idea. And it basically works on the pixel data given to it. And this deep dense face detector, being even though it was the most simplest one that we could come up with, it gave a very good result when compared to the existing ones. And then comes PCA and ANN Fusion. So these two things are put together. So let me first explain what is PCA. So PCA stands for Principal Component Analysis. So given a set of features that we want to pick up the maximum data from a data set that we have. So PCA will help us do that, get the maximum content out of the existing data, like with basically selecting the major part or the major chunk of data and retaining it for the analysis. And the other one was ANN, that stands for Artificial Neural Network. So a fast forward new feed forward neural network was what was used initially. It's actually a type of ANN that only moves in the forward direction and doesn't go around in cycles like the general artificial neural networks do. So, and the data moves in the forward direction and the error travels back, like it propagates backwards basically, and this keeps on happening until the error rate is reduced in ANN, and the model tends to learn more and more from the training data. So that was PCA and ANN Fusion, which also proved to be a very good invention or a very good model that was proposed. And then the last one is hybrid model using deep and machine learning. So in this, as it suggests, it also had deep learning and also machine learning. So deep learning was when it used this RES 50. So this is a convolutional neural network which has 50 layers. So where machine learning comes into the picture is in the last layer. So the out of the 50 neural network, convolution neural networks, the 50 layers, from the 50 layers, 49 layers were maintained, and the last layer that was available, that was discarded, and it was replaced with a classification layer which has SVM, stands for support vector machine, decision trees, to classify if the person was wearing a mask or it was not wearing a mask. That was also a very good outcome that was brought up by the authors. So, as per what I have understood is, the models where there was integration of more than one, they proved to be a very good example or very good benchmark for others. But apart from that, even this deep dense face detector, even though it was a single one, it still happened to surpass the expectations of what we were looking at a face recognition algorithm. So that was my presentation. Thank you.